in this video I would like us to look at the practical diagram of forward and reverse operation of a direct online. We've treated in one of my previous videos, I've treated the schematics. So in case you want the schematic diagram, the circuit diagram is in one of my videos. So in this video we're looking at the practical diagram. With this diagram you can easily construct it. So in my subsequent video we also look at the practical construction, the construction of the panel. So all I want you to do is stay tuned to my channel, and if you have not subscribed, just do well to subscribe so you'll be getting more interesting videos. For I have some good and interesting videos for our electrical engineers, some of us in the industries and the technologies in the high institutions. So these videos will help you. Alright, so like I said, we are treating the practical diagram of the forward and reverse operation of a direct online. We will get to start data and also how to control it, the forward and the reverse operation without interchanging the wires. Just stay tuned to my channel, you get all this. Alright, so as you can see, this, as a direct online is just one contactor, a breaker and an overload. But here we are having two contactors. One is acting as forward and one is acting as reverse. So whenever you want to switch to forward or reverse, you can press this button. So this button is for forward and this is the forward indicator. When it's on forward, this light will come on. When you want to go on reverse, you press this button, and when it's on reverse, this light will come on. All the wiring are there. Don't be intimidated by the arrangement of the wire. It's very simple. I will explain it to you. I will break it down. I'll break it down into power diagram and the control diagram. So you have the stop button. Where you stop, you cannot just switch from forward to reverse immediately. If you're on forward and you want to go reverse, what you have to do is to first of all press the stop button. Then you now press the reverse button. So this is the power light. When there is power in the circuit, this light comes on, and when the circuit trip off, this light will also come on. So this practical diagram is made up of the power and the control diagram. So for us to understand it easily, let's look at it one after the other. Let's go to the power diagram, then the control diagram. So I will show you the power diagram first. This is the power diagram. This is the power diagram. You can see I've eliminated the control diagram, so you can easily understand the wiring of the power diagram. So you can see we have our terminal block where our three-phase 4-wire system feeds in. From there it goes to the circuit breaker. Then from the circuit breaker, where you put on the circuit breaker, it comes on the output and it goes to the one of the contactor. Let's say this is the forward, then this is the reverse. What makes this reverse? Because you can see the wire has been interchanged. In the forward direction it is red, yellow, blue, while in the reverse direction it is yellow, red, blue. You can see. So if you want to move in the reverse direction, you activate this contactor. If you want to move in the forward direction, you activate this contactor. So you can see. So the output of the two contactors are looped together. Then the two contactors, two of them must not be on at the same time, or that will cause an explosion and possible damage to the motor, to the load. So is the control wiring or the control diagram will show us how the two contactors are prevented from coming on at the same time. So you have your overload relay. This overload, when the current being drawn by the motor, is trying to go up, this overload is set in such a way that it will like cut off the control diagram, the control of the circuit. When the control is being cut off, the contactors are off, and the motor power is prevented from going to the motor. So you can see the power diagram. It looks so simple. So you can see very well. Before we go to the control diagram. This is the power diagram. So you can see the red from this. The red from this goes to the red of this. Then when it goes to the reverse, it has been interchanged. You can see it. Pay attention to this. So you can see it. Alright. So let's go to the control diagram. So this is the control diagram. The practical diagram of the direct online. So when you want to construct if you have an operation that requires forward and backward movement, this is how you will do it. So just follow carefully and what you see here. So the control, you can see the supply of the control is coming from the one phase of the supply, which is the red phase. So you can see when it comes, it goes like this. This is the normally close of the overload. Let me bring it up so you see it. This is the normally close of the overload. If this overload is in good condition, if it has not tripped, the current will flow. To flow from this, it will flow from this. You see it. Is the red. Sorry. You see it. You see flow to the stop button. Now a stop button is also normally closed. The contacts are closed already. So the circuit continues. So this is the red. You see it here. You see it from here. It goes to one input of the forward start button, and also you see this one. So also the forward to the input of the reverse start button. You see it in such a way that when you press this forward start, let's say you press this, the circuit goes from this and comes out to the output, which is this blue cable. It comes here, it passes through the normally closed contacts of the reverse. Look at it here. This contact is normally closed. This and this, they are normally closed in such a way that if the reverse contactor is on, the forward contactor will never come on. So this is a kind of a security, an interlock, a safety measure to prevent the two contactors from coming out at the same time, because if they have to come out at the same time, that will lead to explosion, and possible, the motor will get bad. It might affect the motor. So if the reverse contactor is off, that is when the forward contactor can only come on. So this is a normally closed contact. So the signal comes out from this green cable. Just trace it very well. You see it goes like this, the green cable. I'm tracing the green cable. I'm tracing the green cable to this, as you can see. So this is the coil for the forward contactor. So when this side is being energized, the contactor will be activated or energized also. So you see, pressing the forward button will activate this forward contactor. The same thing happens to the reverse. When you press the reverse button, it will activate the reverse contactor, but it has to pass through the normally closed contact of the forward contactor. You can see it. You see it. You see it there. From here, it now goes to the coil of the reverse contactor. This side, the indicators, the forward on and the reverse on. When this contactor is on, the lamp comes on. It's telling us that it is in forward direction, and it is being wired from the normally open contact of the contactor. You know, when the contactor is being energized, the normally open contact becomes normally closed. That's when this light will come on. Alright, same thing applies to the reverse contactor. Let's trace the wire. Then this is the power light. When the breaker is being switched on, the light comes on, telling us that there is power and we are ready to start. And this is the trip light. The trip light, when this overload is being tripped as a result of the currents of the motor being higher than what is being set. You know, this part controls that trip light. This part is normally, when the overload is in good condition and it has not tripped, this part is open circuited, so current doesn't flow. So when it's tripped, this part becomes closed, so the current flows to this and to our trip light. So this light will come on, telling us that the circuit has tripped. There is a problem. It can be as a result of the motor, the load, or the load the motor is driving. It could be a conveyor. The conveyor is stuck, or the bearing of the motor is bad, or maybe a phase of the supply is not complete. You know, when the motor is being powered by two-phase, a three-phase motor is supplied with two-phase, it tends to draw a very high current. So these are the things that can cause a motor to develop high currents and possibly trip the breaker. Alright, so I think it's self-explanatory. So you just have to pay attention and observe it so closely. If you have any question, you can just leave it on the comment section. I will attend to it.